Welcome to a SIM code. Computers and programs. Computers rely on programs for all operations. Users run applications for tasks like word processing, browsing, and calculations. Attackers also run programs to execute cyber attacks by directing computers to execute specific instructions. How programs work. Programs consist of machine instructions executed by the CPU. The computer follows a sequence of instructions stored in RAM. Attackers can introduce malicious programs to manipulate the system. Motherboard, the heart of a computer, contains the CPU, RAM, and input-output circuits. The CPU executes programs and performs calculations. RAM stores active data and instructions for processing. Computer dissection and safety. Only dissect discarded computers to avoid damage. Remove the power cord and wait a few days before opening. Identify motherboard components, including CPU, RAM, power supply, and storage connectors. Replacing CPU and RAM. Many computers support CPU and RAM upgrades. Follow manufacturer instructions to avoid damage. CPUs require heat sinks for cooling. RAM should be installed in designated slots. Input-output I/O components. Connects external devices to the motherboard. Includes USB, SATA, PCI, Ethernet, and video connections, DVI/VGA. I/O devices allow the CPU to send and receive data efficiently. Parallel versus serial wiring. Parallel connections use multiple wires for simultaneous data transfer. Serial connections use fewer wires but can achieve high speeds with efficient circuitry. SATA has replaced older parallel ATA cables due to improved performance. BIOS and bootstrapping. BIOS, Basic Input-Output System, is stored in RAM and runs when the computer starts. Loads the operating system from storage into RAM. Firmware ensures essential functions are operational before the OS takes over. Program execution and CPU operation. The CPU retrieves instructions from RAM and executes them in sequence. The program counter, PC, tracks the next instruction location. Arithmetic and logic operations determine program flow and responses. Multitasking and process management. Modern computers run multiple programs simultaneously. The operating system switches between processes rapidly. This creates an illusion of parallelism even with a single CPU. Operating systems and security. The OS manages RAM, CPU usage, and process execution. Security mechanisms prevent unauthorized access to memory and files. Attackers exploit OS vulnerabilities to execute malicious code. Buffer overflow and cyber threats. Buffer overflows occur when excess data overwrites memory locations. Attackers use these vulnerabilities to execute arbitrary code. Secure coding practices and modern OS protections help mitigate these risks. The Morris worm and historical attacks. The 1988 Morris worm exploited Unix vulnerabilities to spread across the Internet. It leveraged a buffer overflow in the finger service to execute shell code. This attack led to the creation of the first Computer Emergency Response Team, CERT. Access control strategies. Islands isolate processes with restricted resource access. Vaults. Processes must request specific access to resources. Puzzles. Cryptography hides data using mathematical techniques. Patterns. Detect malicious code using predefined malware signatures. Multitasking and process separation. Operating systems enforce separation between processes to prevent interference. Memory protection mechanisms prevent unauthorized access. Kernel mode versus user mode ensures secure execution of system processes. Security policies and implementation. Security policies define protection measures against threats. Implementation involves enforcing access control and defensive mechanisms. Organizations use security frameworks to maintain cybersecurity hygiene. The chain of control principle. A computer remains secure if it only runs trusted software. Attackers attempt to subvert this by booting from external media or injecting malicious code. Secure boot and BIOS passwords help maintain the chain of control. Modern operating system security. Process management ensures fair CPU allocation. RAM protection prevents unauthorized memory access. Modern OSes implement strict access controls for users and applications. Conclusion. Computers rely on structured processes for program execution. Security mechanisms protect against unauthorized access. Understanding computer architecture helps in securing systems effectively.